Hey everybody, Dr. A here, and in this video we're going to be exploring the site characteristics that are involved with the equivalent lateral force method, also known as the ELF method. Now in this video I'm going to be referencing the new ASCE 722 that just recently came out in 2022. If you want some information on the ASCE 716, I have another video where I go through a lot of these same points, but referencing ASCE 716. In this video, I'm going to focus on ASCE 722, and I may sprinkle in there some commentary on some of the things that are updated between 716 and 722. So let's get started. So the soil site classification is going to be categorized as one of 9 site classes. Now, this is a piece of site information or a site characteristic that you need to know in order to go through the equivalent lateral force method procedure when you are calculating a seismic base shear or story forces, for example. So ASCE 722 has 9 site classes. They're labeled as site class A, B, BC, C, CD, D, DE, E, and F. Now this is one of the items that was updated from ASCE 716. If you notice, those of you who are familiar with ASCE 716, we did not have B, C, C, D, and D, E before. Those have been added. Now, the determination of the soil site class is based on the shear wave velocity, which we can abbreviate V sub S, in the top 100 feet of the site. In ASCE 716, you could determine the site class based on shear wave velocity, but you could have also determined it based on your SPT blow counts or your undrained shear strength. Again, that was in ASCE 716. Now in 722, we are only going to be using the shear wave velocity. So in ASCE 722, the specific chapter that includes a lot of these details is going to be chapter 20 of ASCE 722. Now, if you look at these site classes, basically as we go down this list, we go from hard rock, which is site class A, and we get progressively softer as we move down the list. Okay, so as we move down this list, the soils are becoming softer soils as we move all the way down. Okay, so site class E, for example, here is going to be very loose sand or soft clay, and then site class F is going to require a site-specific response analysis to determine its properties and determine how to navigate the ELF method when you have the presence of a site class F soil. Okay, so how do we actually determine the shear wave velocity? Well, the shear wave velocity is a soil parameter that is going to be determined by your geotechnical engineer who is working on the project. They're going to go out into the field and perform some tests, and they'll be able to determine the shear wave velocity and then tell the structural engineer what that is. So it is, in fact, a velocity term. So you want to use it with units of feet per second. So, or we can abbreviate that FPS. So we're going to say that the shear wave velocity has units of feet per second. Now, you do want to calculate the average shear wave velocity in the top 100 feet of the site if you have layered soils. So we're going to make a note here. We're going to say for layered or stratified soils in the top 100 feet, you can calculate an average shear wave velocity. So I'm going to call that V sub S AVG as equal to 100 feet divided by, let me draw a better division bar, divided by the summation as I goes from 1 to N of D sub I divided by V sub S sub I. Okay, so this is a type of weighted average. D sub I is going to be the thickness thickness of layer I. And then, of course, V sub S sub I is the shear wave velocity of layer I. And then N is the number of layers in the top 100 feet of the site. All right, so often your geotechnical engineer will, come across a situation where you may have stratified soil or layered soils, in which case you need to calculate this kind of weighted average of your shear wave velocity. And then knowing your shear wave velocity, you can enter into a table in ASCE 722 chapter 7, and you can determine what that soil site class is. So I'm not going to go into the details and the specifics of the different shear wave velocity values in ASCE 722, but you can look into that yourself in chapter 20. And again, you'll come across a table there that's got the shear wave velocity values associated with each of these site classes, okay? The next attribute of the site that we need to talk about is what's called the risk targeted maximum considered earthquake. Okay, and this is abbreviated as MCE sub R. Okay, now the risk targeted maximum considered earthquake, what we're going to be interested in order to navigate this is what's called spectral response acceleration parameters for two different periods of vibration. Okay, so let's make a note here. We're going to be interested in the spectral response acceleration parameters for a 0.2 second period, which is sometimes called the short period, and for a 1.0 second period, which is called the long period. Okay, now I'm not going to get into the weeds of all the theory behind this. For this video, we're just kind of hitting the highlights of some vocabulary words and what we need to know to be able to navigate the ELF method. Okay, so these two parameters are called spectral response acceleration parameters, okay? And basically what these parameters are, and again, there's two of them. One acceleration parameter is associated with a 0.2 second period of vibration, and then the other is associated with a 1 second period. What these parameters are percentages or decimals of gravitational acceleration, okay? So we're gonna say these parameters are percentages of gravitational acceleration G. And again, I want to be very clear here. The parameters are not 0.2 seconds and 1 second. These are acceleration parameters affiliated with a 0.2 second period and a 1 second period. Okay, so the way we're going to label that is SS. SS is going to be the spectral response acceleration parameter for a period of 0.2 seconds. okay? And the subscript S is like for short, so you can think of that as the short, affiliated with a short period. And then we're going to have S1. S sub 1 is the spectral response acceleration parameter for the long period, or for 1.0 second, okay? Now, these are based on a default site class BC, okay? So we're going to make a note here. These are based on a default site class of BC. Okay. Now, what we need to do, what happens if you don't have a site class BC on the site you're dealing with, right? You got like 8 other options. So what do? Well, you need to obtain what are called the adjusted spectral response acceleration parameters. Okay. So we're gonna say the adjusted spectral response acceleration parameters are given as SMS, which again is the adjusted spectral response acceleration parameter for the short period, and SM1, which is the adjusted spectral response acceleration parameter for the long period. Okay, so put these little quotation marks here. All right. So how do we get these? Well, it turns out you can get SS and S1 from your spectral response maps in ASCE 722. These can come from your figures. I believe it's figures 22-1 through 22-8 in ASCE 722. But those maps are very hard to read, especially if you're reading the physical copy of 722. So ASCE has it been involved with developing an online hazard tool, is what they're calling it. It's called the ASCE 7 hazard tool, which will give you all of these parameters. So we're going to say, make a note here, we're going to say use the ASCE 7 hazard tool and here is the website. It's going to be, you can say HTTPS ASCE 7 hazard tool dot online. And I've used it several times now. I love it. It gives you all the parameters you need to begin your ELF method of analysis. Okay, so finally, to get your design spectral response acceleration parameters, you multiply these adjusted spectral response acceleration parameters by 2/3. Now that step is the same as what we saw in ASCE 716. So we're going to say the design spectral response acceleration params for the short and long periods respectively are given as the following, are given as SDS equals 2/3 of SMS, and then SD1 is given as 2/3 SM1. Now again, all of these spectral response parameters can be obtained from the ASCE 7 hazard tool. So when you go to this website and you use the hazard tool, it will also give you SDS and SD1 for most sites in the GEO database. So so you don't even have to physically multiply SMS by 2/3 if you're using the hazard tool, because most likely it's going to give you SDS and SD1 directly. It'll have a nice table that summarizes all of this. So this pretty much summarizes the important site characteristics that we need to be aware of when we're performing the ELF method. Okay, and again, we're referencing ASCE 722 here, which there's definitely been some changes compared to ASCE 716. So if you're looking for ASCE 716 information, check out my other video, which is pretty much the same theme as this, but referencing 716. Well, hopefully you found this beneficial to you. If you did, please hit like and subscribe, and be on the lookout for other content similar to this. Thanks for watching.